So our topic was motion in a plane, right? Motion in a plane. Example number 4.3 we were solving. So let's see, a motor boat is racing towards the north at a 25 kilometer per hour, right? So make the direction diagram. So this is north pole, this is south pole, this is east, this is west, right? So a motor boat is racing towards the north at 25 kilometer per hour, right? So this is the north direction in which motor boat having velocity that is 25 kilometer per hour, right? Now see the next point. Water current in this region is 10 kilometer per hour in the direction of 60 degree east of the south. So this is east and this is south. So it is making an angle of how much? It is 60 degree, right? With the south. That is VC. Current, water current velocity. Water current velocity. So its value is given, that is 10 kilometer per hour. Understood? So we have to find the resultant. So draw the parallelogram diagram. Suppose resultant is like this. So this value represents R. So draw the diagram. So angle between resultant and VC is given as theta, and this angle I will take as phi, right? And we know the cosine rule of resultant, finding the resultant, that is given by R equal to under root of A square plus B square plus 2AB cos of 60, right? Cos of theta. So see here. So this angle is 60, right? And sum of this angle will be how much? 180. So it will be 120, right? Sum of this angle. So now put the value. So R equal to A value will take this as A and this value as B. So put the value. So A square. So A square is 25 square plus 10 square plus 2 into 25 into 10 into what is the cos theta value? So cos theta value will take as cos of 120. Now solve it. Then we will get as this will be 625 plus 100 plus 25 into 2, 50 into 10, 500. Cos 120 is nothing but it is 1 upon 2. So solve it. It will be 250. This will be 625 plus 100 minus of 250. So it will be under root of 725 minus 250. So how much it is? It is 0, 5 minus 0 is 5, right? So it will be 5. This will be 7. 7 plus 5 is 2, 3, 4, 5. So it will be 7 here and 6 minus 2, 4. So it is coming out to be exactly 22 kilometer per hour. So R value we have got is 22 kilometer per hour. This we have correct calculated. 2 into 25 into 10 into 120. 50 into 10 is 500. 720 minus 250. Right, so it is exactly 22 kilometer per hour resultant value. So right up to this point, then I will tell you the next point. Now see the next point to obtain the angle, right? Phi. So we will apply law of cosine rule. So that we have proved yesterday, that is given by R by sine theta equal to VC upon sine of phi. So you can see on the diagram, this is your R, this is your angle theta, this is VB and angle is phi, right? So that rule I am applying here. So now put the value. So we have to find this one, sine phi, this. So it will be sine phi equal to what? We have taken this one here. So it is VC upon R into sine of theta. Now put the value. So VC is 10, right? So you can see here. This is your VC, right? This is your VC, value is 10. This value is 10. So I am taking that one. So 10 upon R resultant we have got, that is 22, right? That is, we have approximated, right? R as a 22 kilometer per hour. But exact value was 21.8, right? 21.8 kilometer per hour, right? Because under root of 475 is approximately equal to 21.8, right? So now put here, it is 21.8 and sine theta. So theta value was 120. Theta is 120. So it is 10 upon 21.8 into sine of 120 is root 3 by 2. Root 3 by 2. I have taken sine 120 is root 3 by 2, right? So now calculate this one, you will get approximately 0.397, right? So this is your sine phi value. So when we find phi, then it will be sine inverse of 0.397. So it will be equal to angle 23.4 degree. So this is the angle of phi. So please write it down. So next topic is our position, vector and displacement. So it is given by, suppose I am making a diagram for it. Suppose this is your x-axis, direction will be xi, I is unit vector, right? Starting from origin O. And on y-axis, a vector is given, that is y of j. J is the unit vector in y direction, right? O is the origin. So suppose I am taking R as a resultant between these two, right? So now join the points, right? So denote it as a P. So R can be written as R is equal to x of I plus y of j, right? So R is the resultant of x and y, and this is your vector in x direction, and this is the vector in y direction, vector in y direction, right? And j I have told you, so this is the unit vector in y, and I is unit vector in x, unit vector in x direction. Understood? Now
Yes,
see,
sir.
for that I will draw another diagram. Suppose I am taking this as a x and this as a y, right? So this is the resultant value. It is denoted by point P, right? And its value is R, right? So now I will make the some changes. Suppose first join this line, right? Suppose this point moving from P to some point delta P or P dash, right? Join this one and this one, right? So this is your suppose initial position, that is x, right? So changes in x is given by delta x, and this will give the resultant change, right? Now join this line also to get the resultant value, next resultant value, that is R of dash, So this point P and P dash will give you delta R dash, change in the resultant position, right? And this point will give you the change in y axis, right? Initially it was at y1, now it is pointing to y2. It starts from x1 and it goes to x2. Understood? So this position will give the direction of velocity. Direction of v. V means velocity. Understood up to this point?
Yes, sir.
Okay. So right here, R is your position vector. So this will give the position of the object. Position vector. Right. And displacement is delta R. Right. And average velocity is V of a particle. Right. Right up to this point, then I will tell the next position. See the next point or graph. Suppose this is your x-axis, this is your y-axis. This is the position vector, which is denoted by P, right? And it is changing position from P1 to P1, right? And there is some changes in the resultant that is given by delta of R1. Delta of R1 will be this, right? This is R1. So this will give the direction of the velocity, this point. Suppose it is moving from here to here, right? So this curve will look like this, and this will give the direction of velocity. Direction of velocity V. Understood? In the similar manner, I can draw. Suppose this is the same graph, but there is change in the position vector or point. It is denoted by P and it is going to position P2 or point 2. So its resultant will be R2, right? This is R. So this will be give the change in resultant. And join that 2 points in the curve form. So it will give the direction of velocity. Right. So this is for position 1. This is for position 2. In the similar manner, you can draw for position 3, 4 like that and so on. Right. So let's see the next. So how we have calculated delta R? It is nothing but new position minus initial position of the resultant. So this is the change in resultant. Change in resultant value. Right. Now we can express that in the xy coordinate also. So delta R will be given as xi plus yj minus. This will, suppose this is the final point. So it is written by delta x. This is delta y. And initial will be given by x of I plus y of j. So take the common from here. So I will be common. So change in the x position will be x dash minus of x plus. Take j as common. So y dash minus of y. Right. So it will be given as delta x into I plus delta y into j. It is given as delta R. So this will give the position in the resultant. Right. So write this one. Then I will give you the velocity expression. So it is the position vector expression. Right. Now see the velocity expression. So velocity is given by average velocity of an object is the ratio of the displacement and corresponding time interval, right? So it is defined as V bar is equal to change in position by change in time. So this is the first expression, right? So see the next expression. So V bar will be given as delta x of I plus delta y of j divided by change in time, and it can be written as delta x of I by delta t plus delta y of j divided by delta of t. So del change in x by change in time can be written as v of xi plus v of yj equal to v bar, right? So this is the expression for velocity. So please write it down. Now see the next type of velocity, that is called instantaneous velocity. Instantaneous velocity. Suppose this is the graph, right? Position T2, T1. So for a particular point, when we find the velocity, that is called instantaneous velocity. So how it is defined as? It is given by V equal to limit delta T tends to 0. So delta R upon delta of T. This can be delta written as rate of change of position by change in time. So this gives the instantaneous velocity. So write the expression for instantaneous. See the next point. So we have defined velocity. So it is nothing but change in displacement resultant value divided by change in time. Right. So for the instantaneous, we will apply the limits. Right. So it will be limit of delta t tends to 0. So R can be expressed in the form of x and y. So it will be delta x upon delta t of I plus delta y upon delta t of j. Right. So applying limits on the both, then it will be limit delta t tends to 0, delta x upon delta t of I, right, plus j, limit delta t tends to 0, delta y upon delta of t, right? Or it can be written in the form of this whole thing. I will make a bracket. So this whole thing can be written in the form of change in position. So delta x of I by delta t, and this will become delta of y into j upon delta of t, right? In this way, it is defined as. And as we know, delta x by delta t is nothing but it is v of x. So it is v x of I plus v y of j. So this is the instantaneous velocity expression. Instantaneous velocity expression. Please write up to this point. So this will give the instantaneous velocity, right? Now, when we have to find the resultant of this velocity, so how we can find? So v will be under root of vx square plus vy square. So this will give the resultant velocity in x and y. Resultant velocity in x and y direction, right? So when we have to find this will give the velocity, and when we have to find the angle, then it is defined as and tan of theta is given by v of y upon v of x. Then your theta will become tan inverse of vy upon v of x. So this will give the resultant angle. So please write.